So to do the first derivative, you got to use the product rule. Keep one the same. Derivative of the other one, derivative of sine is cos. Plus, keep the other one the same. Derivative of x would be 1. Now, can't factor this. Okay, so that's not good. The only way that at this point, since it's something that we can't solve, maybe you'd see a value right away that you could do, like 0, because you know sine of 0 is 0. So you know that 0 is going to be one of those points. Any other point, though, at this point, you would have to see if you could figure out with your graphing calculator. If there was going to be any other places that this is equal to 0, since we don't have any way to solve it, you would have to use a calculator. Yes?
So like we could move the sine x on the left side.
If we move the sine x. Okay, so that if we move this over and divide both sides by cos x, you'd get negative tan x, right? Equal to x. Well, see, but you're dividing. It is allowed at 0 at this point. It isn't allowed at 0 here because of something you did. And at this point, when you divide by 0, that's what's causing the problem. So as far as, I'm going to take that away, as far as figuring out where this is equal to 0, either we can keep it the way that it is here, x cos x plus sine x, and graph that into our graphing calculator, or you can move the sine x over and graph 1 into y1 and 1 into y2 and see where they intersect. So I'm going to do that second one because it is a little bit quicker when you have two equations in there. So I'm going to put negative sine x onto the one side and x cos x into the other. I'm going to set my window up from 0 to 2 pi. And I'm just going to hit graph to see preliminary what's happening. There's our two graphs. So if I want to find out where those intersect, I can go number 5 to intersect, enter, enter, enter to get one value. That's huge. Make that a little smaller. And my second one on my calculator, number 5, intersect. Now, you might say to yourself, if I have to go through all of this work just to do the calculus part, maybe it just makes sense to use my graphing calculator right from the beginning to graph this. And we'll look at that as well. Yes? Right to the tracing bar. Well, what we're going to want to do is we want to see if we can, how much of it we could do without our calculator. At this point, with this one here, when you realize that, yes, I can't solve this using anything that I have. So the only way I could solve it is with what we have here, which we got 2.03 and 4.91 as inflection points. At this point, it sort of becomes a moot point. Why not just, if I have this graph and I need to graph it from 0 to 2 pi, what would it look like if I put in x sine x to begin with? And then look at its graph from 0 to 2 pi. It's kind of pretty. And then how do we use our calculator to find these things? Well, this point, 0, 0, and this point at 2 pi comma 0, Those ones are going to be easy to see because you know them already, because they'll both be places where sine is equal to 0. You know that this point, here I'll just drag this one over here as well, and then we'll draw right on it. So we know from this is 0, 0, and 2 pi 0. We know that sine is also at 0 at pi comma 0, okay? We would be able to label these maximums and minimums from our graphing calculator. The only thing we can't find is our inflection point. So that's where I'm going to leave you with right now to think about before tomorrow. How do you find, because there's an inflection point right here with your graphing calculator, how would you find that? You could just graph the second derivative, or you could even graph the first derivative and find out where that first derivative has a maximum or a minimum. And then you would find that point that way. So that's where I'll leave you with on this one. Okay? This one would all be a calculator one where you would solve for everything via calculator. There's a couple minutes left. I'd like to give you your test to look at them, and we might go over them at another time.